Okay, so here goes nothing. This is the first time using Explain Everything, so if it takes me a little bit longer or I mess up every once in a while, that's okay. I do want to go through this just because I understand that this is kind of difficult stuff. It's a lot of information, and so I want to make sure that before you actually sit down to study, that you can hear me going through it, even if you weren't in class or even if you happen to be working on our energy lab instead of sitting with me going over this review. So I just want you to be able to participate in what we are going to be taking care of today. So we are going to review for the Sources of Light / Energy quiz. And the very first thing that we're going to talk about is, I know I have complete sentences up here. I'm not too worried about me writing incomplete sentences right now because, well, I'm more worried about the time of the video. So we're going to begin. You're walking with a friend during sunset and you begin to see the moon rise into the sky just as the sun is setting. Explain to your friend the difference between the two sources of light, the sun and the moon. Provide two other examples of both luminous and reflective sources of light. So the sun, gotta get my pen tool. The sun, we will call that luminous. Okay, and that's luminous because if you remember, it gives off its own light. It's its own source of light. The moon, on the other hand, is reflective. And the reason it is reflective is even though we see it giving off light, it is not its own light. That light is coming from a reflection off of the sun. So the sun's light is actually being reflected off of the moon, and that's where we're getting that light from. So two other examples of each. We can go with a, let's see, we can go with a light bulb for the luminous, or we can go with a bioluminescent being. For something that's reflective, we can go with a mirror. So if you're shining light off of a mirror and it changes directions and goes towards something, that light isn't exactly coming from the mirror, it's just being reflected. Or we can go with, I like to think of street signs and how they actually will show up really bright at night, but it's mostly just because your car lights are shining off of them. So street signs. Okay, moving on. Try to explain to somebody the difference between the three light bulbs that we discussed: incandescent, fluorescent, and LEDs, light-emitting diodes. How does each one of these work? So for the incandescent, and I'm just going to abbreviate here, for the incandescent, the difference, or how the incandescent light bulbs work, is that we have a filament. Okay, and that filament is made out of tungsten. And the way that these light bulbs work is that the electricity actually flows into the tungsten. It causes the tungsten to heat up and it becomes so hot that it glows. Now the problem with these is that they produce a lot of waste heat because they are so very hot. It's wasting a lot of electricity. So we've actually begun to ban these and no longer use them. The next one are the fluorescents. Okay, and these work by exciting mercury. Remember that? This is actually where the electricity goes into the tube, and it is exciting mercury, and that is what's causing the glow of the light bulb. This is a lot more efficient as it doesn't require as much energy. The last one are the LEDs, and these are the most efficient. These are the ones that we're really starting to gear towards. These ones are by far the most efficient, and that is because the light comes directly from the current. Okay, so that's coming directly from the current, the electrical current, which is why we're seeing that light. What is energy? Well, if you remember, energy is the ability to do work. Okay, energy is the ability to do work. Explain the transformation of energy that are occurring when a roller coaster is going down a hill. So let's pretend like this is our hill, okay, and we have the roller coaster on top of the hill, and so as the roller coaster goes this way, it is going from up here, it's got all potential and no kinetic, and as it moves down the hill, it loses potential and gains kinetic. At the very bottom, okay, when the cart is at the very bottom, we can go ahead and say that that is where it has all kinetic, no potential. Okay, so as you see, as the cart moves down the hill, it is very slowly losing some of that potential energy because it is transforming into kinetic. Excuse me. Explain the transformation of energy for dropping a ball from a roof of a building onto the street below. Be sure to include terms like potential and kinetic energy. So the same idea really here. We have, let's see, we have, now I'm starting to play with this. So we have a ball, and that ball is going to be dropped from the roof of a ceiling, or the roof of a building, down to the floor. Now when it's at the top, it has our max potential. And again, as it falls, it is losing its potential and transforming into kinetic. When it reaches the bottom, it is at its max kinetic. Okay? And switch to the second page. Oops. Doesn't seem to like my back arrow. So we're going to go ahead and try to erase that. I'm not going to guarantee that erasing that is going to happen. Nope. No worries. Okay, we will just zoom in, if I can ever do it. Zoom in, take a look. Name 3 types of potential energy and provide an example of each. Okay, so let's go with chemical. And we'll go gravitational. And we can say nuclear. And the example of chemical could be batteries, because we know that we have stored chemical potential energy in the batteries because it's actually chemicals in there that are creating the electrical charge. Gravitational, we can use a roller coaster, because we know that it is gravity that is going to take over to allow that roller coaster to move. And for nuclear, we'll call the sun, because as we said in our sources of light, that there are millions and millions of nuclear reactions occurring on the sun's surface, and that is where we receive all of that light. Let's move on to 3 different types of kinetic energy. So the first type of kinetic energy we can say is the obvious one, motion. Okay, when anything is moving, it shares kinetic energy. And so anything that is moving is something as simple as a car. Or you could say you. Okay, maybe you move. Another form of kinetic energy that we're going to go for is thermal. Okay, and thermal means heat. So something that has thermal energy is a light bulb. And the last one we're going to look at is radiant. And again, something that may have that is a light bulb. Okay, or lightning. What is radiant again? Radiant is light. Okay, just remember that radiant energy is light. Okay, so we are going to take care of this part now. The roller coaster, it says to place an X or place an A on the part of the roller coaster that would have the cart containing the maximum potential. Okay, so that is easy. Right at the top of the hill, maximum potential energy. Place a B on the part of the roller coaster that would have the maximum kinetic. So we go to the lowest part of the roller coaster, and that is our maximum kinetic. That is where we're going to have the least amount of potential. If the ride were to start at point B, what kinds of potential energy would you need to get the cart up the hill? Now remember, we talked about this as we watched the video of the roller coaster in class, and we said that it might be electrical. Maybe they're tapping into the electricity to give it that boost to get up the hill, or maybe it is chemical. Okay, maybe they combine some sort of substances to be able to provide the energy for that thing to get up the hill. Besides motion kinetic, what is another form of kinetic energy you would expect to have during this ride? Well, obviously there's friction, so you're going to have thermal. Okay, and obviously a roller coaster, if anybody's ever been on a roller coaster, been near a roller coaster, you know how loud it is. So you could also have sound kinetic energy. Place a C on the part of the roller coaster that you would expect the cart to have equal parts potential and kinetic energy. So we talked about this on the day that we did our notes, and that is going to come right in the middle. So that would be C right there, equal parts kinetic and potential energy. Last one is to identify the transportation or transformations, not transportations, transformations of energy that are occurring between the apple and the bike rider. And this one is pretty simple. We know that we have stored chemical potential energy in the apple, and that is being transformed to motion kinetic. What else could that be being transformed to? Well, we could have thermal kinetic, because we know that we sweat when we're riding a bike. Or we could have sound kinetic. Okay, hopefully this helps you out. I will go ahead and post this as soon as I can, and hopefully this will go ahead and help you out while you're studying. Okay.